And we're back. Part 2. In the last video, right at the end, we had just introduced the formula for a distinguishable permutation. In other words, you've got items that are the same, and when we go to arrange them, for instance, in the word banana, if I took this in and I took this in and I flip-flop places, it would still spell the word banana. If I took the A's and interchanged all the A's, it still spells the word banana. So we don't want to count those overlapping words, so how do we do it? Well, I said on the last slide that you begin with the total number of letters, 1, 2, 3, 4, 5, 6, 6 factorial. Now that would be a standard permutation. But to take care of the different repetitions, here's what I do. I consider each and every possibility. For instance, the B. There's only one B, 1 factorial. Now technically speaking, I don't have to put that because 1 factorial is 1, and dividing by 1, as you know, does nothing. When I go to the A's, I have 1, 2, 3 A's, 3 factorial. And I go to the N's, 2 factorial. And work all of that out, and you should get 60. Now, also in the last video, I mentioned permutations of taking a certain number of elements at a time. So again, here's our situation. We have N total elements, and we're only going to take R at a time. Sorry about that. To figure this out, we will do this. Now, this is similar to the horse racing problem, remember, where we had 8 horses, but we would only select 3, and the order in which the 3 were selected made a difference. It makes a difference whether you finish first, second, or third. Again, think about it like this. If we've got 19 pre-cal students in a class, and I decide that 3 students, now let's make it 4 students. 4 students are going to pass the class. The first student gets an A, the second student gets a B, the third gets a C, the fourth gets a D. Does it make a difference which one you're selected? Well, yeah, it makes a difference because obviously you want an A, you don't want a D. But on the other hand, if I said I'm going to pick 4 students and everybody gets an A, does it matter if you're the first or the last student selected? Well, no, it doesn't. If order makes a difference, A, B, C, D, we use permutation, and we do this formula right here, n factorial over n minus r. Now, I will tell you on your calculators, if you will go to the menu button, and I think it's under probability, you will find this NPR button right here. And feel free to use your calculator to do these permutations. I don't mind doing them by hand. They're usually not that bad, but if you want to use a calculator, that's fine. Now, if order does not matter, you know, you're one of the 4 A's, regardless of if you're the first one picked or the last one picked, it's not a permutation, it's a combination. It's a grouping. How many combinations or groups can you make of say 4 out of 19? Now the formula changes slightly when it's a combination. On the permutation, we did not have this r factorial on the bottom. It was n factorial over n minus r factorial. There's fewer different combinations than there are permutations. And you can play around with your calculator to see that, because within each different combination, let's say I have combinations of 5, if I'm doing a permutation, then I would take each combination and I would multiply it by that 5, or by however many ways I could rearrange the 5 inside of it. So combinations are less, permutations are more. Alright, in how many different ways can the letters A through E be arranged? The order of the letters is not important. Now, I'm sorry, not how many ways can they be arranged, how many ways can they be chosen? So 3 of these letters, 3 of the 1, 2, 3, 4, 5 letters are going to be chosen. Order is not important. So I've got 5 letters, and I'm going to choose 3. So I'll plug in 5 for my N, 3 for my R, or you can work this out on your calculator if you wish. So 5 factorial over 2 and 3 factorial, which does come out to be 10. And again, if you do 5 and then the capital C 3, 5 choose 3, it also will give you 10. Alright, next, how many 10-person committees can be formed from a group of 20? So again, we've got 20 people, we are selecting 10. So we'll do 20, choose 10. Again, you can put this into your calculator, or you can plug 20 in for N, 10 in for R, and work it out. And you see that of 20 people, if you're making 10-person committees where order does not matter, mind you, that's important, 185,000 approximate different groups. Now, one of my favorite examples. Let's play cards. A standard poker hand consists of 5 cards dealt from a deck of 52. How many different poker hands are possible? After the cards are dealt, the player may reorder them, so order is not important. So you've got 52 cards. You are selecting 5 of the cards. So we're going to do 52, choose 5. So it's going to be 52 factorial over 47 factorial, 5 factorial. Now, what in the world does that work out to be? Well, certainly, you could use your calculator if you wanted. About 2.6 million different hands. Certainly not good odds if you're wanting to get a specific hand, is it? Alright, the number of subsets in a set. Now, this is an interesting problem. Find the total number of subsets that has of a set that has 10 elements. Now, what is a subset? Well, a subset is a group within a larger group. So, for instance, you might say, how many groups of 0 can I make out of the set of 10? How many groups of 1? How many groups of 2, 3, 4? And a subset can include, in some situations, the entire set. So, how many sets of 10? So, here's how we're going to work the problem. See if this makes sense to you. We're going to start out by saying, okay, out of 10, how many groups of 0? Out of 10, how many groups of 1 and 2 and 3, and all the way over here to out of 10, how many groups of 10 can I make? Each of these is a subset within the whole group of 10. And if I want to know the total amount, I take, okay, how many of these can I make? How many of these? How many of these? And I add all of them up. And pause the video if you want, but add all those up on your calculator. I would not work those out by hand, although it's not terrible to do. 1,024. 1,024. Which, by the way, if you are interested in shortcuts, happens to be 2 to the 10th power. There is a shortcut formula that says if you have n elements, the total number of subsets is 2 to the n power if you want to do that. So if you had 8 elements, for instance, you would do 2 to the 8th, which is, I think, 256. But you could play with it if you want. That formula is in your book if you want to look at it. Now, ladies and gentlemen, again, you've done 2 videos, and I've probably moved quickly through them. Feel free at this point in time, while you're waiting for class to finish, to go back through the first or second video, watch more of it, work on this homework assignment. But by all means, come in tomorrow and ask, or I shouldn't say tomorrow, I should say Friday, or Monday, because you're watching this on a Friday, and I will answer what questions that you have. I'm also going to put this video on YouTube and on Planet High School. If you want to look it up by the title of the lesson, or by my name, or by both, so that if I went a little too fast, you can go and pull up that video and watch through it again. And we'll see everyone on Monday.